Alright, so welcome back to a brand new video. Today I decided to do a collision feature. So I've got this checklist on my notebook in front of me. Things to do in Arki. Move methods for objects, done that. Animation objects, check mark. Audio loader, have not done that. Save objects to JSON, have not done that. Collision detection, have done that. Haven't done that. In Gravity, I have not done that. So I'm thinking today I'm going to do collision detection because it's the simplest and I'll be able to display my results better than another, like through video, than another task that I could be doing. So like collision detection, once I complete it, it'll be easier to show you via this video um, what I've done compared to like if I did save objects to JSON. It's just a little harder to show on video like the results that I gained from adding that feature. So collision detection is only inherited by a game object. Why? Because UI doesn't obviously collide with other things. So all we can do is in the game object, you can see I have the move methods. Just say move methods, and I'm just gonna say collision detection. So first method is gonna be public void on collision, and public void on or so that's gonna be on collision, and we're gonna say during collision public void on collision exits collision, just like that. And let's change this to on collision stay. Alright, so we have, let's just grab this, put that there. So we have on collision exit, and on collision stay. So on collision is invoked when the specified object is collides with a different object, but it's only called once. Okay, you know what? I have an idea. So let's delete this method. And actually, sorry. So I'm trying to think, do I need to add an on collision stay, or should I put a boolean that represents whether the object is currently in collision with another object? So let's see. If we have a boolean, then we'd have to check in the tick method. And yeah, you know what, let's just keep on collision stay. So okay, so let's just write some notes. So this is going to be detects when this object collides with another detect, or you know what, let's say invoked when object collides with another object, when this object, and we can say invoked when this object what do I see? Exits collision with another object. So let's say the object is currently overlaying another object. So when it stops overlaying, then that method is called. Invoked recursively during an object's collision. Alright. Let me just make sure I've got the definition right. Oh yeah, so I had this weird error. It kept giving me an error whenever because I created this random R variable and for some reason it wasn't working. And it was such a weird error because, you know, it worked for all of the other objects I created. Okay, so recursive meaning. Just make sure I got this definition right. Relating or involving the repeated, okay. Program a root line of which parts require application so that, you know, whatever. I think it's right. We'll just stick with it. Okay. Sorry, one second. Sorry, somebody in my class got COVID, so, you know, just making sure he's okay. So we've got our on collision, exit, and on collision stay. And now you're starting to see why I don't like making videos while I'm coding, because I've already spent 6 minutes just making these 3 methods because I'm explaining everything when I could have done it in 5 seconds. Sorry. Okay. Yeah, sorry. I was texting my friend. Anyways, on collision. Sorry. Okay. So on collision stay, on collision exit. So on collision, so when we collide with another object, we are going to be using the bounds of the object, right? So when we collide, I'm gonna bring up paint. When we collide, we're gonna, let's say we have a box, this is our boundary. There's another box. And we want to detect whether this collides. Well, we're gonna see if if there's a point anywhere inside of this box that is within another box, within this box, if one of these points within this box is within this box, this other box, then it's colliding, right? That's essentially what collision is. If any points within a box is inside of another, is within the area of another box, then it's obviously a collision. So what we're going to want to do is the boundaries are defined right here by this space inside. So the y is greater than this x position, or than this y position, but smaller than the y plus the height's position. That's essentially how we define the boundaries. Okay. So we do have a bounds object inside of the entity manager, or the entity object. Yes, bounds. Now, I'm not sure. Okay, so the bounds is equal to a rectangle that takes in the x, y with. Okay, so we already have a bounds, it seems. What we can do is okay. So we want to check if an object is colliding with another object every time it updates its position, right? So I say that we create a class, or not a class, a method called, this would be a private void check, or you know what, it would be public void check collision, right? So this checks collision, and this would be called every time the position is updated. Okay, wait a minute. No, because if another object collides with this object and it's not moving, then we would still want to detect it. Never mind. So we would want to do it in the tick method because it's happening recursively, no circumstances, or all circumstances. So we can just say tick. Public void tick, that's an overridden method because it's implemented from this abstract entity class, and in this we can do public void check collision. So we can check the collision. Check collision, right? And okay, so another thing that we do want to add, so let me just write this down in my notebook, is collision detection. A child's goal is to make it solid and collidable. Not sure if that's a word. Solid, or I don't know, collidable. I'll just put that for now. So let's just square that in. So if it's solid or collidable, that will be a toggleable attribute. Is toggleable a word? Toggleable. Yeah, toggleable. That's a word. So those will be toggleable attributes. But we'll do that later. So in our tick method, we're of course going to check collision. Now, let me just print out something to make sure that check collision is called. Okay. Oh, my bad. I forgot to zoom in, so you guys can't really see it right now. So you can see I made the tick method right here, the check collision method, all that. So let's go into the sample objects, and you can see we have a tick method, right? And I forgot how it works, but if I don't do super.tick, will it still call this, whoops, will it still call this check collision? Will it still call whatever's in here? Whoops, didn't mean to debug run it. Whoops, run. Stop and run. No, doesn't seem like it. So, because I told it to print out high if it does. So if I go down here and do super.tick. Okay, now it works. Alright, so that might be a little problematic because I want it to be as convenient for the game creator as possible. So it checks collision automatically. So when it's ticking, it's going to check collision. So let's see. That's not going to work. So we could just leave it to say super.tick. Right? And that would automatically check collision. Or what we can do is say check. We can. You know what? No, let's just leave it like this. So whenever we want to check whether it's colliding, right? No, that's still inconvenient. Okay, my bad. I'm going back and forth here. To check collision, where are we invoking the tick method? So why don't we e.check. Okay, whoops, I forgot check collision isn't part of that. This is infuriating. Game object. Check collision. We're just gonna have to leave it like this. So it's gonna check collision every time we tick. And in order for this to work, we're gonna have to call super dot check collision, and we're gonna do that after we move, obviously. Super dot check collision. All right. So You know what? Super dot check. Let's do that. Because we're gonna move, and then we're gonna check. You know what? Whatever. I don't even care. Check collision, and when we check collision, we're gonna want to get the bounds with each object, I believe. Okay, let me go over to my engine B. There's gotta be a better way than just looking through each individual object in the scene and comparing the values. Move X, move Y. Okay, so in my previous project, I literally just I looped through all of the entities. Okay, I guess we can do the same. But we are okay, yeah. So what we can do is say for entity for, can we do this? For game object E or O in entity manager dot sorry, is this all entities? All entities? It's not public, is it? Private. Okay, so let's make a getter. Public static array list of entities called get all entities, return all entities. Alright, so we can just go over here and say get all entities. Game object O, okay. Change parameter O to type. Okay, yeah, so we'll do that. And we'll say, first we'll say if O dot get class, I think dot dot child. Check if class has inherited method Java. Is that how you would say that? Check if, oh, if it has a subclass. Check if class object is a subclass of another object. Yes, okay. So class dot is assignable from, I would have never guessed that. If O dot is dot class dot is assignable of the game object dot class. So this dot class, if, there we go. So if O dot get class is assignable, so let's just make sure this works, and I'm just gonna print out test. Okay. Check collision. Okay, yeah, that's probably it. So if this basically checks if this entity is a game object. So we'll say if it's not a game object, then we'll just continue, right? However, if it is, then we'll execute the following code, which is check if so we'll say is colliding. Boolean is colliding. Right. Okay, this is annoying. check collision. Okay, so we're gonna want to check the collision, but I want to make this a separate method. So we'll see. We'll say, you know what? You know what? Let's go into the entity manager and transfer that over here. So we can say down here, we can say public static array list, and we'll call, this will be a game objects array list called get all game objects, right? And all we can do is, let's go over to here, cut this out, right? Go into here, paste that, and we can say if it is assignable from game object class, then we're going to add it to an array list. So array list of game objects called all game objects. We'll say all game objects dot add o. And then we'll have to cast it, of course. And then we'll just return all those game objects, right? So now back here, we can say for game object o in entity manager dot get all game objects. We'll say we'll have to check whether it's colliding. So if o dot so first we have to check if this specific game object is the same game object as the one that this method is inside of. So we'll say if o dot equals to this, then we'll continue. However, if it isn't, then we're going to say if o dot get bounds, or if o dot bounds dot contains. What's the difference between? Oh, okay. So if that okay, so we'll nope. If it intersects with this dot bounds, then we're gonna call the three methods accordingly, right? So on collision, each of these methods are going to want to be invoked, but we also want to get the information of what object is it being collided with. So we're simply going to pass in game object, we'll say collision or collider, right? Alright, so the easiest to do is just do the on collision stay. So on collision stay, and we'll just pass in O as the collider. So now let's run the program, see if it works. Doesn't look like it did. I just saw those two colliding. Oh, whoops, I forgot to implement it. So let's go to sample object. Wait, could you guys see? Yeah, you could. And we'll say over here on collision stay, because that's the only method we have set up, say print out colliding. Let's look in the console. And when one of the cubes collides with another one, then it should print out colliding in the console. None of them collided the one time I fixed it. Alright, I can't tell. Why don't I go over to the actual class? And let's just keep it from moving. Or, sorry. Keep it from moving. And instead, let's comment that out. And we'll say if, or, yeah, no, if alright, sorry. So, you know what? Alright, so let's do, we're just gonna have the square focus on, we're just gonna have the camera focus on a random cube on the screen, and then we're just gonna be able to move that cube around. So we'll say entity manager.focus cam on this. That'll just pick a random one, because you'll see when I run it, see it focused on this one. And then we can say then we can say if entity manager dot get did I not make a method? Dot get camera dot focused entity. Okay, we'll just do that. If entity dot, so right now we're just trying to check if the collision is working. Collision detection is working. So if entity manager dot camera dot focused entity equals to this, then we can check if key manager dot is held. We'll get the character W. We'll say y speed equals to 5. If key manager dot is held s and y speed equals to 5. This should be -5. If key manager dot is held a, then x speed is equal to -5. If key manager dot is held d, then we'll just say x speed is equal to 5. So this piece of code basically just checks if the current entity is the one that it's focused on, and if it is, then we're going to detect when we press a key, and when we do press a key, it's going to move in that specific direction. So you can see I can now move. Okay. I forgot that it can't stop, so let's, oh no. It's not colliding. Or it is, but it's not detecting it. Could this be because I have to put this here? Nope. Nothing. Alright, why don't I first fix this? So we'll say we'll just say else if for each of these, right? it doesn't have to be anything fancy. It doesn't have to really make much sense right now. Else, we're just gonna say x speed equals to 0, right? And y speed equals to 0, because this is all just testing right now. So now when I press WASD, it should stop. Yep, there we go. Yeah, no. Okay, for some reason it's not colliding, or it's not detecting collision. Okay, let's just make sure it's... Okay, yeah, that's working. Let's print out o.get.name. Forgot they all had different names. I mean, the same name. If o.bounds. Okay, so there must be something wrong with the bounds, right? Which must be inside of the entity. So let's see this bounds. Where do we set it? Right here. Bounds equals to a new rectangle. Int x with height. How did I do it in my old project? Wait a minute. Oh, wait, no. Yeah, open. How did I do it in my previous game engine? If e.collision bounds intersects, and it passes in the offsets. Get collision bounds. Could that be the problem? Check collision bounds, or get collision bounds. Alright, you know what, let's, let me print out bounds dot. What will that print? Will that print like an object? Okay, yeah, that's, oh, that prints the object and all of its values, perfect. X, Y, width, height. Perfect. Okay, so the bounds is equal to... Oh, wait. X? What is X? Oh, okay, so we'll just have to do get display X, get display Y. Those methods automatically cast it to an integer, right? So we can just delete that. Oh, now it's just infinitely colliding. Get world X. That's so odd. Okay, so we'd be checking if the world's X. No, it would be get world X, get world X, get world Y. Check if that is colliding. It's not. I gotta be doing something stupid. Let's print out this dot bounds plus spacer plus o dot bounds. Let's do that. X is 830. Alright, let's remove a few of these objects just to make it easier. Crap, now I have to find no idea where the other object is. Let's just keep running until we find it. Or maybe I'll have to set it to 0, set the position to... I'm an idiot. I removed all but 1 instead of 2. There we go. Oh. Okay, so it's constantly colliding. Alright, so X is 8. X is 98. Wait a minute, game object. I think I know the problem. There should be get display X, get display Y, right? These are the same ones. Get world X. Okay, it should be get world X. Alright. Oh, I think I know the problem. So okay, so I think the problem is that I'm not updating the collision bounds. Told you it was something stupid. So if I go into my entity class, go over to my bounds, this dot bounds equals to a new rectangle. That's just called in the constructor. Return. Okay, so I solved that in that project by just using a getter. So what I can do is say alright, so in the getters we'll just say display position getters, yes, getters, so we'll say public rectangle get current bounds, turn new rectangle. Alright, that's gonna pass x, y, and then width and height. So get world x, get world y. You know what? Just do get x, get y, get width, get height. And over here in the game object, okay, now it should work, right? Oh, no. Instead of this dot bounds, we'll say this dot get current bounds. Alright, so now we're getting the current boundaries and not the initial boundaries. Now when we collide with this, yes! It's colliding. Exit. Alright, so let's delete this. And let's look in the console. When I run this, okay, nothing's being printed. Nothing's being printed. When I collide with it, colliding, exit, stops printing. Colliding, stops. Perfect. Alright, so that method is being invoked. Alright, that method's being invoked. And let's just do that. How long is this video? Whoops, did not mean to open Steam. 40 minutes, that's pretty long. I usually don't code this slowly, by FYI. This is just because when I'm recording, it takes me 3 times as long. So on collision exit and on collision. So that's going to be a bit trickier. I have an idea. What we can do is we can have a protected boolean, and we'll call this is colliding. Set that equal to, we'll set that equal to false to begin with, alright? But then, when we collide, we can say is colliding equal to true. So, when it first collides with an object, that means that is colliding is false. So we'll say, so let's just delete that, and we'll say if is colliding, if it hasn't been collided, but it's just now colliding, we'll call all on collision, pass an O. Now, when it exits, that's a bit different, because it's no longer intersecting. So we'll say, if it's not intersecting, then we're going to check if it was colliding, and then we're going to say, on collision exit, pass an O, and now is colliding is set to false. Alright, let's try it. On collision stay, put these above here on collision, and that's just, whoops, say on collision exit. And why don't we just say, we'll just print out collided with collider.name. Why isn't that? Whatever. Collided. We'll just say collided. I'll fix that later. So, when it just collides, let's zoom in here. So, it should only call once. When I collide with this, it should only call it once. Oh, it called it twice. Alright, you know what? Let's ignore that for now. Check if on collision exit works. Sout exit, run this. So, shouldn't call anything, which it isn't, because I haven't exited, but once I exit, it calls it. Perfect. Oh, I see. It's printing it twice because both objects um are are invoking this one method. Sorry, both objects are printing out the same thing. So what I can do is say, wait, can I access? Okay, yeah. So what I can say is, um, you know what? No, it's fine. Okay, so yeah, both methods work. So we've got our collision done and ready to go. Thank you all for watching. See you guys next time. Bye.